Okay, so we start with a picture. As you can see, it's strange that when I picked up these two photographs, at least the architecture and the colors of the sky and of the buildings of Parma and London are very similar too. So it was a nice coincidence. I have to thank my University of Parma. I have to thank naturally the King's College London. I have to thank the supporter who gave me the possibility to join physically here and to travel to London. And naturally, it has to be the title of the reason why we are here. The title of the paper that was published in 1953, the 4th of September, the day today, was a fascinating event. And these are the two guys who made this dream come true today. They were able to put things together and to realize that there was something important going on. What was important going on? No, the paper is only 2-page long, so it's not very impressive in length, but it's very dense and it goes to the core message. There are at least two messages that I would like to share with you. One is that these phenomena, these EEG patterns, these eye movements do not occur randomly. So there's a sort of clock or periodicity of control inside the brain and the body, which allows them to be organized in a very software fashion. It's not left to random or to chance. The second interesting point that was highly appreciated and was a breakthrough also for the media was that this state is closely related, although not exclusively, but preeminently to the oniric activity, to dreaming. Bill Dement was not in the paper, was not among the authors, although he was starting to be a main character. In fact, in 1957, 4 years later, together with Nathaniel Kleitman, he published two relevant papers, one continuing the insight into the relation of eye movements during sleep and the relation with REM activity, so a very robust confirmation. And the other thing is that they were trying also to use the REM sleep paradigm to understand the cyclic variations and to create the premises. And then in 1968, when there was the Rechtschaffen and Kehl's guidelines, we will have the definitive and final classification of REM sleep and non-REM sleep. In the meanwhile, there was another giant who was working in France, Michel Jouvet, who was trying to understand if this sleep, this new type of sleep, was also could be investigated in animals, in cats. He was the one who coined the interesting term paradoxical sleep in alternative or integrating to REM sleep. He also was the one with these experimental studies in cats who created the premises to understand what Carlos Schenke and Mark Mahal will in 1986 discover as the REM behavior disorder. And here are the four giants sitting in the same room, satisfied, excuse me. In 1995, we were in Nashville, Tennessee, and celebrating the 100th birthday of Nathaniel Kleitman. So the four of them were there, and we were all glad to have them. Here are the other two giants that I said before, that in 1986 published for the first time a paper, important paper, on the description of this REM sleep parasomnia. This is another guy that was a possible participant to this meeting, and I was there in 2000 at the meeting of the APSS. So excited to hear when he first presented the preliminary data showing the difference between controls and narcolepsy with these orexinergic neurons in the hypothalamic area. What is interesting, and now I would like only to put a sort of a list of questions. I don't have answers, so because you are the experts, and you are the ones who today will help us to shed light on some of these apparent contradictions. As you can see, when Eugene Ozerinsky published his paper telling the story of how he explored and investigated for the first time REM sleep, he used to call it NEM period. So the no eye movement period was the non-REM, because there was these jerky movements called GEM. So but as you can see, it was strange. People, although they were EEG experts, well, Eugene Ozerinsky was also an expert of explosives, by the way. If you read his biography, it's very interesting. But it's curious to see that we generally score and investigate sleep by means of three basic information traces: EEG, EMG, and EOG. But it's so peculiar that still today, 70 years later, we're using only an electrooculographic pattern. So I have tried to share with you this impression. I'm like a rover going around exploring a new planet, and I'm trying to have some curiosities. I'm curious like the machine. So the first is definition. Why are we still classifying the entire sleep architecture based on electrooculographic feature, rapid eye movement? And what is not rapid eye movement becomes non-rapid eye movement. It's the same thing that we did with Terzano when we discovered CAP. We said CAP and non-CAP, following this kind of negative opposition, which is probably not very elegant, because maybe in the future we should try to understand if there are alternative options in definition. By the way, REM sleep occupies only 20% of the night, while the other 80% is occupied by what is not REM sleep. By the way, the French school has proposed paradoxical sleep, as you said before, or sommeil paradoxal, and doesn't call it non-REM sleep, it calls it sommeil lent, so en lent. So this is an interesting point that we could discuss later. The second one, this is, I grateful to Jerry Siegel, who some years ago presented a very interesting pros and cons debate on homeostatic concept. Now, we always consider homeostasis as something that pertains to the slow wave sleep. The Zurich school, Borbelli and his team has always built up a powerful slow wave sleep centered narrative, and even the very interesting discoveries and studies of Tononi and his group are trying to underline the connection between memory selection and dynamics, downscaling, so on. So it's always, homeostasis is always linked to non-REM sleep and slow wave sleep. But Jerry Siegel, and we all know in our clinical experience, there's a rebound also if we selectively deprive REM sleep. And in fact, if we have a REM dominant sleep apnea and the patient is put on CPAP, the first thing that appears as soon as the patient is able to breathe is a rebound of REM sleep. So even REM sleep has an homeostatic pressure. The third curiosity is the fact that there is this periodicity, this cyclicity. We know that there's a cyclic alternating pattern in non-REM sleep, but we don't know if there is a similar condition of periodic arousals or of periodic features, like say saccadic eye movements, twitches. So Jim Horn once told me, hey, listen, why don't you look at the combination of REM and eye movements? Probably eye movements could have a sort of intrinsic periodicity inside REM sleep. Or are we missing all this periodicity because arousals cannot be organized in a cyclic way because REM sleep is an intrinsically anarchic condition? The fourth curiosity means that there is a stage distribution of sleep-related events. There will be presentations by Lino Nobili and by Federica Provini, by Robert Thomas, on the fact that something happens almost exclusively in non-REM sleep. For example, epilepsy, night terrors, sleepwalking, PLMs, periodic breathing, chain stalks respiration, and they disappear when REM arrives, or they are less influenced by that. On the other side, we know that there's an REM dominant and non-REM dominant sleep apnea, and probably also Robert Thomas can tell us something on the different, not only different clinical features, but also on the different treatment. Sleep groaning, on the other side, is a more typical or prevalent feature of REM sleep. So are these different due to the peculiar organization of arousal in non-REM and REM sleep? Are they due to the different electrophysiological background, e.g. synchronization dominance, e.g. desynchronization? This is another important open issue. Two sides, same coin, same moon. We're always, I've always been fascinated by the fact that most people in the sleep field, there's somebody who always investigates REM sleep, and somebody always is very keen on non-REM sleep, on clinical or experimental side. But it's strange because in RBD, in narcolepsy, in neurodegenerative diseases, not only REM sleep is altered, but also there are macro and microstructural alterations in non-REM sleep. And on the other side, in non-REM, we also know that, for example, in parasomnias of non-REM sleep, in SHE, sleep-related epilepsy, REM latency is modified, is longer. There are, in major depression, there are modifications both in non-REM and REM sleep. Benzodiazepines, antidepressant treatment, they are influencing both REM and non-REM. So is time ripe to approach sleep in a more holistic way, not as a collection of separate rooms, but as a single apartment? That's an open question. Next slide, if it goes. Thank you. Dreaming is another important and open issue. We know that we dream mostly in REM sleep, but we also know that we can dream in non-REM sleep. So are we celebrating the anniversary of a misleading discovery? And maybe somebody today can open us this door and clarify. And the last four curiosities. Number 7, if we dream also out of REM sleep, why is muscle atonia present only in REM sleep? And the other question is, why is REM sleep, although it is modulated by homeostatic processes, why is REM sleep located at the end of the sleep cycle, and why does it prevail in the second part of the night? So is it optional, or is there a hierarchy? But I know that somebody of you has already ascertained that it seems that in the phylogenetic evolution, REM sleep appeared before non-REM sleep. So this is an open question. The 9th curiosity, and I'm sure that Dieter Riemann will help us to disclose this concept of hyperarousal. Is it only a REM sleep affair? Is it a general condition of the entire sleep recording? So involving also non-REM sleep, and this is very important for insomnia. And finally, there is an evolutionary role of REM sleep. Is the different length of REM sleep in the animal world simply an ecological adaptation to the different environments or temperature, or is it somehow linked or reflecting cognitive, intelligent functions? 1953 was not only the year in which we celebrate the discovery of REM sleep, but also the structure of the DNA. And also, we should always remember that together with Watson and Crick, there was a lady there, there's a woman, a very, very smart woman, Rosalind Franklin, who should be correctly remembered and honored. Now, as you can see, there's the DNA is something that is very similar to the cyclicity and to the organization of sleep. And it has been also a way to think about how we can use dreaming and genes and sleep as a background to create art. So putting all together all these in my REM word cloud. These are the principal things that I've tried to focus on, and I would like you to collect these words and also to implement them. And I'm sure that your presentations will shed light on some of these strange questions and curiosities that I wish to raise with you, and thank you.